Hi guys, this is the homework video for week number 2. Again, like last week, we're gonna do, since we're kind of reviewing phrasing merit, we're gonna do a combo. Both classes are doing the same work. So the algebra class and the 8th grade class will be doing the Pythagorean theorem. So I have some problems set out that I'm gonna go through, but I also wanna show a clip from the channel, the math channel that we were looking at last week, the Math Antics. So I'm going to show you a little bit of this, and then I'm going to show you something else on YouTube that I want you to just see visually. And then we'll talk about some problems and how to actually like approach solving some stuff.
Okay, now that you've got all that background info covered, let's see what the Pythagorean theorem actually says. The theorem can be stated in several different ways, but the one we like best goes like this. For a right triangle with legs A and B and hypotenuse C, a squared plus b squared equals c squared. As you can see from this definition, the Pythagorean theorem doesn't apply to all triangles. It only applies to right triangles. As you know, right triangles always include one right angle that's usually marked with a square right angle symbol to help you identify it. And you need to know which angle is the right angle because it helps you identify an important side of the triangle called the hypotenuse. The hypotenuse is the longest side of a right triangle, and it's always the side that's opposite of the right angle. In other words, it's the side that doesn't touch or help form the right angle itself. In order to use the Pythagorean theorem, you need to be able to identify the hypotenuse because that's what the variable c stands for in the theorem. C is the length of the hypotenuse side. The other two sides of the triangle, the ones that do touch or form the right angle, are called its legs. Our Pythagorean theorem definition uses the variable names a and b to represent their lengths. Oh, and it doesn't matter which leg is called a and which leg is called b, as long as you keep track of which is which after you make your initial choice. Okay, now that we know the various parts of the Pythagorean theorem, let's think about what the relationship or equation a squared plus b squared equals c squared is really telling us. It's telling us that if we take the lengths of the two legs, sides A and B, and square them, which means multiplying them by themselves, a squared is a times a, and b squared is b times b, and then if we add those two squared amounts together, they will equal the amount you'd get if you square the hypotenuse side, which would be c squared or c times c. That may sound a little confusing at first, so let's take a look at a special example of a right triangle that will help the Pythagorean theorem make a little more sense. This right triangle is called a 3, 4, 5 triangle because its sides have the relative lengths of 3, 4, and 5. And by relative lengths, I mean that the units of length don't really matter. The sides could be expressed in any units, inches, meters, miles, whatever. So the triangle could be of any size as long as its lengths would have the proportions 3, 4, and 5 relative to each other. Starting with the side that's 3 units long, which we'll call side A, what do we get if we square that side? Well, in arithmetic, squaring 3 means multiplying 3 times 3, which equals 9. And the geometric equivalent of squaring something actually results in a square shape. As you can see, this square contains 9 unit squares. So this red area represents the value a squared in the Pythagorean theorem. Next, let's look at the side that's 4 units long, which we'll call side B. Squaring 4 means multiplying 4 times 4, which is 16. Again, the geometric equivalent of that is a literal square that is 4 units on each side and covers a total area of 16 units. So this blue area represents b squared in the Pythagorean theorem. And finally, let's deal with the hypotenuse, or side C, which is the longest side. It's 5 units long. Squaring 5 means multiplying 5 times 5, which is 25. And the geometric equivalent is a 5 by 5 square that has an area of 25 units. So this green area represents c squared in the Pythagorean theorem. Now that you can see how the arithmetic parts of the Pythagorean theorem are related to the geometric parts of this right triangle, let's check to see if the Pythagorean theorem is really true, at least in this special case. On the arithmetic side, if you add up the amounts a squared and b squared, they really do equal c squared because 9 plus 16 equals 25. And with a little rearranging of our unit squares, you can see that the area of the squares formed by the
So right now he's explaining the idea that those two squares that make the legs up, so that a squared and the b squared literally are the same area as that larger square on the opposite side. And so I wanted to show another video that was similar in demonstrating that idea. So keep in mind that this a squared plus b squared equals c squared, this is an equation that's written, with algebra. And algebra didn't exist when they were actually doing this math in Greece. So Pythagoras wasn't talking about letters and plus signs and equal signs like this. They were literally talking about squares. Like if you take a right triangle and you build a square off each side, it'll add up to the same area as the square off the opposite side. So that would look kind of like this. Notice this is the same problem that he was doing in his video also. Okay, so this would be considered like a visual proof that one of those squares added with the other squared for the A and the B side physically adds up to the C side. All right, enough of these videos. Let's do some math. So the first topic for the homework is really just a review, and actually some of you have already done it. So you can look and see if you have a score, but you should make sure you understand it. So this is IXL topic NNA. And really all it's saying here is it's asking you which number would you plug in and square to equal 16. And so hopefully based on all the stuff we did last week, you would know that's 4. But it asks for 2. And the reason is, and that's kind of why I chose this to do this week, because I just wanted to talk about it, 4 times 4 equals 16, a positive 4 times a positive 4, but a negative 4 times a negative 4 also equals positive 16. So really this has 2 solutions. And the second solution is negative 4. So either the answer is a positive 4 or the answer is negative 4. Okay, moving on. So as I went through this topic, all the problems basically stayed the same. The only thing that changed was that some of the numbers were a little bit bigger. So the square root of 400, you can still be referencing, like a list. You're trying to memorize them still if you haven't already. So the square root of 400 is 20. So I can either do 20 times 20 or negative 20 times negative 20, right? 20, negative 20. Okay, so this is the second topic for this week. And so this is topic EQZ. So topic EQZ. And really what you're trying to do with this is you're using the Pythagorean theorem to decide, is this a right triangle? So your answer is really going to be yes or no. And I'm positive some of you will just sit there guessing and answer 300 questions until you get up to 80. But there is a pretty easy mathematical way to do this. Really what you're saying is that this is a leg, and this is a leg, and this is the hypotenuse. And so how did I know that this last one was the hypotenuse? Because it's the biggest. So the biggest is always going to be the hypotenuse. And really, you're just setting up that equation, that a squared plus b squared equals c squared. And this is a great opportunity to get good at using a calculator. So you don't need to be doing all this math in your head. So this would be 7 squared plus 15 squared equals 17 squared. And then if you do end up memorizing a lot of those, then this makes it a little easier because you don't have to punch in all those buttons on the calculator. So I have 49 plus 225, and I'm checking basically to see if it equals 17 squared, which is, I believe, 289. Let's double check. Oh, 10. Yep, 289. So is 49 plus 225 is not. So this, and it makes sense because 9 plus 5 obviously is not going to total up to a 9. So 274, and this one's 289. So since they are not equal, then the answer here is no. So it's really all you're checking. If I do the same thing here, let's erase all of this. So same thing. This time, I just have bigger numbers to deal with. So this is at a SMART score of 60. And it looks like the hypotenuse this time is going to be the 95, right? It's the biggest. So I'm wondering, is 65 squared plus 72 squared the same as 95 squared? And I don't know. So it's really a question mark there, right? And so if I pull up my calculator, 65 squared. Oh, I keep having the pen on accidentally. Is 4,225 plus 72 squared, which is 5,184. And so if I add those together, I end up with 9,409 on this side. So that's what I'm checking is this number going to be that? So let's check, which I'm going to say no, right? I'm doing 5 times 5, so how is that going to equal 9 at the end? But let's double check so that you can see the process from start to finish. 95 squared. Oh, it's close. 9,025. So definitely isn't quite right. So these do not equal each other, which means that the answer is no. All right, so deciding if it is a right triangle or not is something you can use the Pythagorean theorem for. Is your triangle a right triangle, or does it have different kinds of angle measurements? Like obtuse or acute, that type of thing. All right, that brings us to what you can, the other things you can do, which is to find missing sides. So definitely something you can use the Pythagorean theorem for is to find one of the sides when they're missing. So you'll notice this triangle has a missing side. So the first topic is 7ZL, and this one is finding just the hypotenuse. So basically I'm saying this is a leg and this is a leg. And so I'm trying to figure out what the hypotenuse is. So, you know, my formula is a squared plus b squared equals c squared. And I need to remember that really is saying leg squared plus leg squared equals hypotenuse squared. And so the first step is just to fill these numbers in. That's the first thing I want to do, is just to come over here and take these different numbers here for each side and put them into my equation. It doesn't matter which leg is which. You can move those around because they're just adding. So it doesn't matter which order you add them in. So I have both legs. So I have 54 squared plus 72 squared, and then that equals c squared. So c squared is the one I don't have. And so if I go back to my trusted calculator, I have 54 squared. You know what? I'm going to do something different. I'm going to stop using this calculator because it's not very easy to use. And I'm going to come over here and I'm going to go to Desmos so that you can see why Desmos is so awesome. So if you don't have a calculator to use that you like, you can always go into Desmos and use it. It's free. The calculator is. And the nice part is it will do order of operations for you. So you can type in 54 squared and then add 72 squared. And it'll tell me that the answer there is 8100. And that equals c squared. So back to my problem then. If c squared equals 8100, hopefully you can tell why we were looking at those first problems. When you go back up to the top here, these first couple that I was looking at, where you're saying f squared equals 16, so you're trying to figure out what number. Really what you're doing is you're taking the square root of both sides. And we talked about that last week. So the opposite of squaring is rooting, right? Remember that root operation? So that's what I want to do, is I want to get rid of this squared by taking the square root. And whatever I do to one side, I have to do to the other side. So if I take the square root of c squared, I have c left. And then if I take the square root of 8100, I end up with 90. So this time I don't need to worry about the negative. Why is that, do you think? Because it's a distance, or a length, I guess would be a better way to say it. So this is a length, and you can't have a negative length. So we were just going to talk about it as the positive answer. Okay, let's try another one just like that. So like I said, that topic 7ZL, that one is just finding hypotenuse. So the next one is the same way. And even look at that, it's the same problem we saw before. So let's go through and you can watch me do it this time. But basically, again, just like last time, since my right angle is here, that means this is the hypotenuse. And then that means that this is a leg and this is a leg. So I need to put leg squared plus leg squared equals hypotenuse squared. And in this case, my legs are 3 and 4. So 3 squared plus 4 squared equals c squared, which is really 9 plus 16, which is 25. And then since I am trying to get rid of that square symbol here, I'm going to take the square root of both sides, which leaves me with c equals 5. So not too bad. It's definitely the kind of thing that the more you do it, the easier it gets, because you just remember the process more clearly. All right, let's go down and do the last two problems. So the last topic has you solving triangles, but this time you'll notice you're missing the leg. So if I look, this is topic Y9C, and it talks about missing legs. So here, if my hypotenuse is across from the right angle, then that means I have it this time, it's 10. And so this is a leg and this is a leg. So I have a squared plus b squared equals c squared. A this time is the one that they're calling the thing we're missing or trying to solve for. So I'll plug 8 in for b and then 10 squared. So a squared plus 64 equals 100. So this is kind of why we were practicing those squares last week, so you could get good at that part. And then if I subtract 64 from both sides so that I can solve, for a squared, I have a squared equals 36. And just like I did before, to get rid of that square symbol there, I'm going to take the square root of both sides, and I end up with a equals 6. So not so bad, right? Okay, last problem. Okay, so same situation here. You'll notice, though, instead of calling the missing side A, they called it B, but it's the same thing. Remember, A and B don't matter. They're both just legs. So this is my hypotenuse, and then this would be my leg and my leg. So I have let's do a squared plus b squared equals c squared. A this time is 2. And then c is 8. So this turns into 4 plus b squared equals 64. And then if I subtract 4 from both sides to get rid of that, I end up with b squared equals 60. So this is a good example of how many of the problems will be. They won't be whole numbers. You will have situations like this where you're going to have to take the square root of a non-perfect square. So you'll end up here with b is whatever the square root of 60 is. But still good news, you can still use a calculator. So let's go into decimals and type it in there. So the square root of, well, pen. I have to get used to all these new systems. 60 is 7.75 if I round. So that's what I will do. Okay, so it was 7.745. So the 4 makes it not round. See here, if I go back to my pen. So you're looking at here, it says to round to the nearest tenth in the instructions. So I'm looking at the 4 to see if I should round the 7, and I shouldn't. So 7.7 is what I get. So I almost wrote it in the box. 7.7. So this was 7.74. And so I look at this to see if I should round or stay the same, and I stay the same. Okay, I think that's all the things that I wanted to talk about. This is not so bad. Usually what I tell students is that if you're the kind of kid that needs to understand why something works, then hopefully you already have enough information for that. If you're the kind of kid where just memorizing a process works a little better for you, and that could, you know, get better as you get older, you may not have to rely on that as much, then this is pretty easy as far as process. You're either going to be searching in every problem, either for the hypotenuse or a leg, right? So you're going to have one of these things missing in each problem. So it'll either be this leg or this hypotenuse. If you're missing the hypotenuse or the leg, you really start the problems the same way. And you do that by squaring both numbers. And that's really the same step for either type of problem, because you're always going to set up two numbers in the equation where they're going to be squared, right? Because that equation is a squared plus b squared equals c squared. So you're always going to have two and be looking for one. And it's either going to be that hypotenuse you're looking for or the leg. But either way, you still have to square both numbers that are there. So that step is the same. If you're looking for the hypotenuse, then that means you have a squared and b squared, and they're together on the same side of the equation like this. So you're just adding them together. If you have the leg, that means you would have a situation where you would have something like c squared and maybe b squared. So they're on opposite sides of the equal sign. And so instead of adding them, you are going to subtract them because they're on opposite sides. So in order to combine them, you have to subtract. And then the last step is, again, the same for both. The last step is to take the square root of the number that's left. So if we end up working together this week, if you need help or whatever, I'm probably going to end up showing a list like this again so that you can see that really all these things are the same. The only thing that's different is this middle step here. You're either going to add them together or subtract them, depending on if the two numbers are on the same side or if they're on opposite sides. Okay, I have a feeling we're also going to spend a little bit of time on this next week just to make sure you understand it. So you will have another opportunity to practice. Okay, let me know if you have questions, and you can definitely come to my office hours.